So today we're looking at C++ development. We're going to talk about a couple different components for this. This is for our Introduction to Data Structures class for CS 2420. The first thing we're going to start off with today, we looked at this a little bit when we looked at our projects the other day in class, but with C++ we have what's called a pound include statement. The pound include statements are how we import information into our projects to include it with our projects. And so like I said on the notes, it's like the idea of the import statements of Java and Swift. It has the idea of how you access libraries. However, unlike Java and Swift, there are different ways of doing pound include. We have two different styles of pound include statements. We have the angle bracket pound include, and we have the quotes pound include. The angle bracket pound include is for built-in C++ library structures. So these are the ideas of the libraries that are built into it, whether it's a standard library template or whether it is a built-in library that's part of just the C++ library itself, where you have access to things that are already part of the language. Where those ones use the angle brackets for something like, in the case I gave in the notes, of IO stream. So dealing with input and output streams, we have that right there, so we have access to the whole thing. We have, for our own internal imports, or includes, we have the idea of the double quotes. And with the double quotes, we use a path structure for that. That path structure would start with a dot to go up a level, and then a slash, and then a model, and then some file.h. So if we were going to go into our model package, our model library for that, we'd use that same idea, and so we use the quotes on the ones that we build ourselves. So if we're going outside of our package structure or our container structure, we'd use the quotes with a dot slash to get to the appropriate directory, and we'd use that as minimal as possible. With the idea of the the pound includes, is you only want to include what you need in that file. You don't want to add unnecessary includes. So it's kind of how we were doing it with the idea of Java, where we did the import java.util.ArrayList when we were only using ArrayList, but when we used a lot of things out of java.util, it's, we'll include java.util.asterisk. Same thing when we did our Android dev. If we were only using one widget, we just imported the widget. But when we started adding lots of widgets, we imported the entire widget library. And so the pound include is, you want to actually only use the component pieces you need. So don't include, if you don't use something, for example, some file.h, then don't pound include it. So be restrictive on your use of pound include. Only include what you need to have. And you'll identify that because it won't compile. Okay, that's actually a quick way to find it. If you need to use something, you'll pound include it, and then write your reference to it inside your code. And we'll see how that works here in just a minute. Now, you notice right here that I pound include only the .h file. We'll talk about the pound includes more in just a bit, but when you use the pound include, the only thing you're importing is the header. The actual implementation file is handled on its own. That's fine, that's dandy. The pound include gives us access to the header information, so we can use that in the actual process of the code itself. The implementation will get called as needed. The next thing we're going to look at is the idea of C++ file structure. Specifically, we're talking about the file structure for building classes. We are going to be doing our C++ in an object-oriented way. C++ was designed to be object-oriented. It's not quite as object-oriented as some other languages, like say, for example, Swift and Java, because it still includes everything that is C, and C by its nature is not object-oriented. But we have the ability to make it more object-oriented by the way we build our code. And so we're going to use a file structure for this. One of the biggest things with that is the C++ file structure is a split structure. Now in Java, we haven't had a separation from our headers and our code. Our code and headers are all in one single file. And because the implementation happened at once, because we use that one single file, our .java file, to generate our .class file, which is what ran. In C++, it is a little bit different. In C++, instead of having simply just a CPP file for everything, we have what's called a header file and a CPP file, or implementation file. The header file is where we put all of our prototypes or method headers, aka the structure of the class itself. And we'll go into more detail on that. The implementation file, or the CPP file, is where we write the actual code that makes that happen. So we're going to use that idea of structure, and it makes it so it's more lightweight. So that way we don't have to have all of our implementation and our structure in every single file. We can only import the structure we need, and then it'll automatically refer to the implementation when necessary. So for C++ purposes, it does save us some time. In Java, it wouldn't save us time because the way the structure itself is built, it wouldn't actually help us with that. We are going to continue using folders to organize our projects and our files. Within that, we have at our root of all of our projects, we'll have a source folder, SRC, just like we did with Java. We're going to continue using that process. On top of a similarity with Java, we are going to continue with our model view controller structure. We are going to be doing only a console-based view, so our view is going to be fairly simple. But we will have a view package structure set up. But we are going to continue with a model and controller structure where we're going to use the controller to operate and define the model and then send that information to the view as needed. And we're going to, even though we're using console-based structures for that, we're going to have that set up so we can use that as necessary with C++. We're going to try and keep our code organized. It's really important that we have the idea that we can reuse our code. That's one of the reasons for this, especially on MVC, is it allows our code to be reused, and it will make it so that we can make changes to our code so that, oh, we've seen this code in C++, now we're going to make the changes we need to make this happen in Java. And we'll actually do a couple of practice assignments with that, where we'll make the code in C++ and make it, we'll immediately translate into Java because the code itself won't be a big change. We'll just have to do a couple basic formatting things for syntax issues, but the code itself will already be ready for us. And so we're going to see that happen here in class a few times so that we can directly import that model view structure within our projects. So let's talk about the header file next. The header file is the .h extension. So .h for header is where we're going to see that information. These will be kept in the same folder as our CPP folder. The implementation and header are not separated out by folders. They're merely separated out by the packages they belong to. Our H extension for a class project, or for one that we're making a class or an object file. When we want to deal with that, we have some preprocessor info. Now in Java, we haven't used the preprocessor info very often. The only preprocessor info we basically used was the at override, the at test, the stuff that we're doing when we're using our JUnit or we did our Android development to talk to specific parts of the compiler. Within C++, you send lots of messages to the preprocessor. That's actually something that happens quite often. And in this case, we use the pound if and def, pound define, pound indif. Now, this is not an if test, but rather this preprocessor notification is saying, if you've never seen this information before, let's define it. And then we define it with pound define, and we end that with the pound indif. There are different conventions on the pound if and def for what we put after that. You can use, some people do that in all caps with underbars to separate that. We'll be figuring out right now. I'm going to use the idea of mixed case notation. We don't need to use this very often. What this does is the pound if and def, pound define, pound indif says we are saying that this header file right here is the only one with this information in it. It's forcing our code to be so that we know exactly what's in our header files so we use the right ones. And so we'll be putting that in there so when we do a header file for a class or for an object, we will put that basic name in there so we have that information so we have access to it. So for all of our object-oriented stuff, our header file is going to have this. Now, there are a couple files that will not get .h files, like our runner. Our runner doesn't need anything else it's not part of a class. The runner is not object-oriented. And that's one of the reasons why it's not going to have a header file. In a header file, unlike in Java, in C++, this is where the only spot where we put our visibility and our definition of class. So we define our visibility sections in the header file, and we define the actual class itself in our header file. And it is a very different way of defining the class in Java than it is in C++. So we're going to see that here in just a bit. In our header file, we need to make sure we have all of our data members defined, all of our methods, our constructors, and our destructor. Need the prototype, aka just the header for that method. So it doesn't have any of the stuff that goes inside the squiggles. Rather, it's literally just that first line. The method return type, the method name, and any parameters it has, followed by a semicolon. One of the things this is most similar to in Java is the idea of creating an interface. We will have a public section, though. We'll have private sections, because the private and public is not differentiated inside the actual implementation file. So our CPP file has no reference at all to the whether it's public or private. The public or private is only visible and only identifiable inside the header file. The CPP file that's associated with that automatically has access to all of that information because it's inside the class. But external classes will only know by looking at the .h, what they can see and what they can't see. And so the .h is how we identify what is visible and what is not visible, what can be seen in other classes. And so we will make sure we define our getters and setters as public. We'll put that inside our header. We'll put all of our constructors in there. And in C++, we'll get a special thing called a destructor, which we'll be talking about more tomorrow. We also have our class implementation file, aka the CPP file. CPP is the C++ standard extension. You might see some older extensions with .cc. There's also C++ files. I haven't seen those very often, but that's what I started off with when I was learning C++. The class name prefix is going to be found throughout the code for a class implementation file. So if your class is named Monkey Toast, then you have Monkey Toast : and then whatever it is after that. So the class name prefix will be in front of all of the methods and constructors. And it's going to show how we have the ownership or that structure of object-oriented programming. And we have that : which is the scope resolution indicator. It says that this thing belongs to that class. Whether it is the method, the constructor, the destructor, or otherwise, that scope resolution indicator, we'll see that inside our code, is how we identify that it belongs to it. So it'll have the name of the class, : and then either the name of the method or the name of the constructor. And so as you can see right there, we have the class : method, params as needed. It will be that basic structure inside our code. That's only inside the .cpp file. In our implementation file, we implement all of our component pieces, aka we give all the squiggles to our code. We assign values to our data members. We put our pieces together so we can use them. The order itself inside the CPP file does not matter, but because we have that .h file, we have to go through and actually implement everything that's in the .h file. It really does make sense to follow the order of our .h file inside our .cpp file. Oh, I have this, then this, then this. Oh, and here in my CPP file, let's put this, then that, then that. The idea of keeping our code as simple and as easy to organize as possible is a really great idea. One of the weird things about C++ compared to Java is the implementation has no reference itself to whether or not it's public or private. When you write that implementation file, when you write your private methods, you can't tell in your implementation file whether it's public or private. The only way you have access to the knowledge of public or private is by looking at the .h extension file. And those are actually what are most often passed to and supplied to the other programmers so they can use it as an API, is they just get past the .h files. You don't know what happens inside the .cpp. You're just given, here's your .h files, this is what the code can do. And in fact, some of the assignments we'll be doing in class, I will be giving you a .h file, and your job is to write the CPP file from the .h and from the documentation and comments. So just look at what's inside that, then write the information that goes along with it. We have I/O in C++. Input, output. We use system.println inside Java and scanner objects to do reading console input. In C++, console input is actually even easier than it is in Java. It's one of the things where C++ is actually much easier than Java as a language. So the basic things we have for C++ are cin, cout, and carr. Cin is console input, cout, console output, and carr, really crazy, console error. Weird. Now, these are not methods that we are used to using in Java, as we saw in our little sample video the other day, but rather these are it's a structure that's built into it. These are specific things that are built in the standard library. We'll be using them all the time, but they do require special operators. Cout and carr operate in the same basic principle, where they use the less than symbol together. Cin uses the greater than symbol. And we're going to use some yoda references right here so to actually understand how they work. So if you look on the notes right here where it says stuff here is going to console output, but to console output stuff here is going is the yoda version. So it'd say cout, angle bracket, the stuff you want to print to console output. So think of it kind of like Yoda, how Yoda speaks inside the prequels and the original trilogy of Star Wars, where he has that backwards set of speech. That's kind of the way it works for the idea of cout. It's directing at that. The same thing on the console input. The console input is going in this variable. So we're going to take the console input and we're going to shove it into the variable. So it's a very different way from Java. We've already seen that in the video. We'll put some screenshots of some code attached to this as part of that here in a minute. But we have the idea that we have that reference of information and how we are going to send that through within I/O. And so we have the actual standard output symbol right here for cout, where it says cout, angle brackets, some quotes, text that would go inside that, another set of angle brackets, followed by the end L indicator, aka ending the line. This is how you get system.println. And then closing, of course, with our great friend, the semicolon. Semicolons in C++ are your friends, just like they are in Java. We'll actually be writing probably more lines of code, so we'll see even more of our great friend, the semicolon. For console input, it's in the format cin, angle bracket the other direction, and then the variable name. So you're directing the console input into that variable name. The arrow indicators tell you where it's going. So with console output, that stuff, the quotes and the inline, are being directed to console output. On the input, the console input is being directed into the variable name. So there is a directionality is what those arrow brackets indicate. As I said, the C-error, we could substitute C-out for C-error, it'd be the same thing, just saying it's a console error, just a different way of logging that information. Now, within C++, we want to make very, very sure that we match our variable type to the type of input we are directing into it. Otherwise, we'll get an exception and we'll crash our app. And we don't want to crash our app. So it's, again, whenever we use the console input, we want to make sure that we are grabbing the appropriate value and put it in the appropriate location. And so we'll talk more about type safety and stuff and how to make sure we check for information going proper, just like we did in Java. We'll do that same approach here in C++, but we want to make sure we do that properly inside C++ as well. And so I/O is just pretty basic for that. I/O and pointers. Now, we've talked a tiny bit about pointers. I want to bring it up right here, just so it's immediately starting in your notes. We started using pointers on the first set of video notes. We're going to use pointers in class again here today, but we want to make sure we start using that immediately and start practicing with it so we can see the idea of it. But with I/O and pointers, it's kind of a big deal. We want to keep track of that. You want to make sure when you're using pointers and printing or directing output that you're using the right thing. This is just in general for pointers in itself, but specifically with output, we want to make sure we actually get that properly. So the variable itself, if we're using just a regular variable, we can just print that variable out and it'll print its contents out, no problem. However, if we're printing the pointer, we want to make sure we print the dereference value. We don't want to print the address of the pointer 98% of the time, probably even 99% of the time. The address of the pointer is not what we actually need. The address of the pointer is just that memory location. And most of the time, we don't need to actually see the memory location in our program's output, on the screen, in a file. It's only there to verify we've got the right file. We're talking about the right variable. And so that's only for check purposes that we would ever need to have the output of our address, basically. And so we don't have to, that's not what we're going to be worrying about in class. But just as an FYI, when we print this out, we want to make sure we print out the dereferenced value. So vocab word dereferenced, especially when we use that when we're dealing with pointers values. So we have that pound include for the header file at the top of the class. We have our class name prefix with a scope resolution indicator. Again, the scope resolution shows the ownership of those methods and data members. And it has the class name : method, any params as needed. So to see that again over here and the actual sample of that code, we go to our controller.cpp. And where I have my constructor, my methods, my other method, and I have that using namespace, which gives me access to output, which we already talked about. But we have that same idea where I'm putting them in the same order as I see them inside my header file to keep it easy for me to understand. I start off with the prefix of the class name in front of the scope resolution. It's highlighted all the way down. After the scope resolution indicator, aka who it belongs to, I then have either its constructor name, its method name with parameters or without parameters, and again another method name without parameters. Squiggles work the same in Java as they do in C++. They denote blocks of code. Semicolons work the same. They end statements. We have our this pointer, which every object has access to, which allows us access to internal references. So we can talk about the current object. And so I will encourage you to always use the this pointer, especially in C++ dev. It's even more helpful than it is in Java. And in Java, it's quite helpful. We use the selector indicator. Say this means that I'm using a pointer, but I want to get access to the methods that belong to that pointer. So this pointer is talking about a silly app controller. So the arrow indicator or the selector says this works like a dot if I was actually using a reference of the object instead of a pointer. Because I'm using a pointer, I need to use the selector. If I was using an actual object, I could just use the dot, but we'll be using pointers 99% of the time, so we're going to get used to using that arrow indicator. We use the same ability to change values like we did inside Java, where we use the this pointer to refer to the current object. And we return just like we do in Java. It returns a single value in one line. Again, we saw the order itself didn't matter for the implementation. We just had to put it in. We talked about I/O, that we have some input and output happening. Looking back at that I/O right here, we go back to the screen. We have the console output. What am I directing to console output? I'm directing that sentence in the silly apps start method. And then I close it with an indel. If you guys notice that on that apostrophe, I use the backslash in front of it. The backslash I use with apostrophes because I'm indicating that it's not going to be used to denote a char type. It's an escape sequence, so I'm saying it's okay to use the apostrophe. We have our cout. Notice that our arrows on cout are pointing that the text is going into the console with the arrows right here. So these arrows indicate that this text right here is going into the console. So I'm going to use that start method to call those existing methods. And so I'm going to use that right here. I could simply call get count like this. So cout, angle brackets, get count, parens, angle brackets, indel. Actually, let's do the angle brackets, quotes, space is the count right now. So I'm adding a call to an internal method inside my code. Again, notice because it's internal, I don't have to use the this reference. I can, it's a good idea to do so, but I can simply call internal methods just like we have in Java. And so I'm going to print out the current value of count from that constructed value. I'm going to save this. I'm going to build it. Now the question was to go back up to the top. And so I added the #include IO stream to get access to the input and output streams. And I also added the using namespace std, which gives me access to cout cin. Let's test this out and see how well it worked over here. So I'm going to restore my screen. I'm going to go to this new version. I'm going to go down to run as local C++. And as you can see inside my console window, that I was in the start method, and my count right now is 99, and my application is terminated. So that did end. It printed out the value and then it stopped. I can go make a change to that, and inside here, I'm going to say cout, angle brackets, quotes, indel, and type in a new value for count, please. Cin, other angle brackets, because I want to have this so that it will be that what is there is directed into the from console input into this, and I'm going to direct that into a variable. And so I actually need to declare that variable. So int temp count. And I'll store that into temp count. And then I'm going to assign temp count to set count. So we'll say set count parens temp count, and then copy pasta. At this point, I figure it's okay to occasionally tell you to copy and paste. We have some fairly standard lines of code that we'll use often. In this case, copying a single cout statement or a single Java print statement. We don't need to worry about the actual depth of the code on that. Rather, we simply just need to repeat that process we've done a bunch of times. So again, I save my code before I execute. I command B to build my code. I build all. And I could choose run second C++ by pressing the lovely play button. And if you notice right now, I'm in the silly apps count start method. 99 is the count right now. Type in a new value. And you notice that my app is not stopped yet. I have that red stop sign saying, oh, I can stop my app right now. But I want to actually type in a new value for count. What's a good number to be for my new count? 4,523 is what I heard.
24. Yeah.
I'm going to press enter, and it takes that variable right here from temp count, and it takes the console input and stores it into there. It then takes that now temp count variable I defined and sets that into set count, which goes up here. It puts it into that variable, directs it from count into this .count, which refers to the current instance of the silly app controller, and then comes back out to get count and repeats that value, returns this .count, and takes the get count and directs that to the updated count, as you can see right there. So we can see the fact that we actually have the transfer of control from methods and classes inside this file. So we've learned some new stuff in C++.